Hello and welcome to our session on foundational artificial intelligence risk mitigation strategies. Today, we are going to explore how to architect systems that are private, secure, explainable, and robust from the very beginning. We will also look at how standard change management applies to these advanced systems. Understanding these concepts has immense real-world utility for your career. When your company wants to purchase a new vendor tool for the human resources department, you will use these exact frameworks to determine if the vendor built the tool safely or if they cut corners. Furthermore, if your internal engineering team is building an automated customer service agent, you can step in to ensure they are designing it to withstand real-world attacks and protect user data before a single line of code is written. The incredible rise of generative artificial intelligence has naturally sparked significant concerns around data privacy and digital security. A major reason for this anxiety is that some models are inherently non-deterministic. Non-deterministic simply means that the system might not give you the exact same answer every time you ask it the exact same question. Think of a traditional calculator as deterministic. 2 plus 2 is always 4. An artificial intelligence is more like a human chef making a soup. Even with the same recipe, it might taste slightly different each time because the chef reacts dynamically to the environment. Because we cannot easily map out the exact inner workings of these complex models, organizations must proactively ease user fears by adopting what we call privacy by design and security by design. Let us break down privacy by design first. This is a globally recognized framework that mandates embedding privacy controls directly into the foundational architecture of technology, business processes, and even physical infrastructure right from the start. It is the difference between mixing chocolate chips into your cookie dough before baking, rather than trying to press them into the cookie after it comes out of the oven. The goal here is not to stop enterprises from using data. Rather, it is a blueprint for ethical data management. It allows companies to keep delivering great products and marketing while ensuring data remains safe. Most importantly, it gives consumers default control over their information without forcing them to navigate confusing menus or complicated opt-out procedures. There are 7 core elements that make up the Privacy by Design framework. Let us walk through each one so you have a complete picture. Element 1 is being proactive, not reactive, and preventative, not remedial. This means anticipating and neutralizing privacy risks during the early planning stages. It is like checking your car tire pressure before a long road trip, instead of waiting for a tire to blow out on the highway. Element 2 is privacy as the default setting. If a user does absolutely nothing and never touches their account settings, their privacy must remain completely intact and guaranteed. You do not have to ask a car manufacturer to install seatbelts. They are just there by default to protect you. Element 3 is privacy embedded into design. This requires treating privacy and security with the exact same level of respect and attention as system speed, functionality, and usability. Element 4 is full functionality, meaning positive sum, not zero sum. A zero-sum game implies that if you gain privacy, you must lose user experience. Privacy by design rejects this trade-off. You must engineer solutions where security and functionality exist on equal footing, creating a win-win scenario for everyone. Element 5 is end-to-end security, which provides full lifecycle protection. Privacy must be guaranteed from the moment data is collected all the way through its processing until it is safely and permanently destroyed. Imagine checking a bag at the airport. You expect the airline to guard it from the ticketing counter through the flight and right up until it lands securely in your hands at the destination. Element 6 is visibility and transparency. Enterprises must keep data processing open and visible to demonstrate accountability to regulators and build trust with users. This is exactly like a restaurant having a glass wall looking into the kitchen, so diners can clearly see their food being handled safely. Element 7 is respect for user privacy. While businesses have legitimate interests in processing data, the ultimate overriding goal must always be guaranteeing the rights, freedoms, and privacy of the human beings whose data is being used. The user must remain at the center of the universe. Because these models require massive volumes of data to learn, understanding these privacy concepts is an absolute necessity for developers. Different global regulators have adapted these ideas, For example, the United Kingdom Information Commissioner Office, known as the ICO, created a widely recognized privacy model consisting of 7 distinct principles. Principle 1 requires processing personal data fairly and lawfully. Principle 2 dictates that data must be processed only for specified, explicit purposes. Principle 3 focuses on data minimization, strictly limiting the amount of personal data an enterprise may hold. Principle 4 demands keeping personal data accurate and entirely up to date. Principle 5 sets limits on retaining personal data, meaning you cannot keep it forever. Principle 6 outlines the specific rights of individuals. This is a big one. It includes the right to request access to their data, the right to seek recourse for damage or distress, the right to prevent direct marketing, the right to allow or challenge automated decision-making, the right to correct inaccurate information, and the right to seek compensation for any privacy harms. Finally, Principle 7 requires robust information security to protect the data at all times. Shifting gears slightly, let us look at secure by design. Just like privacy, this is a process that ensures cybersecurity considerations are woven into a product from the very first day of development. It relies heavily on defense in depth. Defense in depth is a strategy where you use multiple, overlapping layers of security. If an attacker breaches the front door, they still have to get past a motion sensor, an alarm system, and a steel safe. A crucial component of this is being secure by default. This means technology products must come equipped with defenses against the most common cyber threats without charging the customer extra money to turn them on. If you buy a house, you expect the front door to come with a working lock. The builder should not ask you to pay a premium subscription fee just to keep intruders out. There are 3 main principles of secure by design. First, the manufacturer must take total ownership of customer security outcomes. Second, the organization must embrace radical transparency and accountability regarding their security posture. Third, they must build specific organizational structures and leadership roles dedicated to achieving these security goals. Now we arrive at a fascinating challenge unique to artificial intelligence, which is explainability. With typical software, a human programmer can read the source code and understand exactly how the program operates. But these new systems are different. Modern models are trained on billions of parameters. They self-learn patterns and encode these findings into high-dimensional matrices. Let us simplify that jargon. Think of a parameter as a tiny dial or knob. A model has billions of these dials that it twists and turns on its own to figure out a problem. A high-dimensional matrix is essentially a massive, impossibly complex mathematical spreadsheet that the computer builds in its own language. Because it creates this web of logic independently, humans struggle to fully explain exactly why the system made a specific decision. However, regulations do not accept ignorance as an excuse. The General Data Protection Regulation in Europe gives citizens rights regarding automated processing. The European Union AI Act takes this further, granting individuals the right to an explanation when a system makes a decision about them. So, how do organizations achieve explainability when the technology is basically a black box? They must adopt several detailed documentation techniques. First, they must explain the overarching governance structure, detailing how privacy, legal, security, and human resources teams oversee the system. Second, they must clearly explain what personal data was used to train the model and detail the exact controls used to process user opt-outs. Third, they must explain how they collected consent from data owners to use their information. Fourth, they must document the data cleaning process, which is how they removed errors from the training information before feeding it to the computer. Fifth, they must detail the security controls that restrict access and prevent malicious tampering with the dataset or the algorithm. Sixth, organizations must thoroughly document the system design. This includes documenting hyperparameters, which are the overarching configuration settings set by human engineers to guide how the machine learns. They must also list the evaluation metrics used to measure success. Finally, the 7th technique is to explicitly explain the entire training, evaluation, and validation process. This includes proving that due diligence was performed through adversarial testing, bias testing, and toxicity testing to ensure the system does not produce harmful or prejudiced outputs. Next, we must ensure our system has robustness. Robustness means the application continues to function safely even when hit with unexpected data, changing environments, or malicious cyber attacks. The core philosophy here is to expect the unexpected and ensure that if the system does fail, it fails safely. Imagine an elevator that loses power. A safe failure means the emergency brakes engage and hold the car in place, rather than letting it drop. To build a resilient system, you must implement specific techniques. First, design the architecture with strict data input validation and sanitization. This mitigates attacks like prompt injections. A prompt injection is when a malicious user types a trick phrase to confuse the model into breaking its own safety rules. Sanitizing input is like checking everyone's pockets for matches before letting them into a fireworks factory. Second, during inference processing, which is the time when the model is actively answering a user question, the system must protect its own resources. It should use limits and throttling to prevent infinite processing loops from crashing the server. Throttling is just like a dam regulating water flow so the river does not flood. Third, you must proactively build in error handling for common issues, allowing the system to react with backup plans. Fourth, if the application realizes its outputs are dropping below defined metrics for accuracy, precision, recall, or safety, it must automatically shut down or default to a safe mode to prevent harm. Robustness is an ongoing job because conditions change continuously. Data patterns evolve, human cultural norms shift, and underlying computing infrastructure is updated. Therefore, post-production monitoring is absolutely essential. You cannot just deploy a model and forget about it. Furthermore, artificial intelligence introduces entirely new attack surfaces. When a new technology hits the real world, hackers immediately test its boundaries. Security teams must go beyond conventional protection. They have to guard against data and model poisoning. Poisoning is when an attacker secretly slips bad information into the training data, essentially teaching the computer the wrong lessons on purpose, much like slowly mixing salt into a sugar jar so the baker ruins the cake. Teams must also defend against instruction substitution attacks, where the application is tricked into swapping its core instructions. Finally, let us discuss change management. Even though this technology feels like magic, it still shares the exact same operational goals as conventional software applications when it comes to making updates. When altering a system in production, you have two primary objectives. First, all impacted stakeholders must be clearly informed about what is happening. Second, the negative impact on service quality and availability must be kept to an absolute minimum. You achieve these goals exactly the same way you do in traditional information technology. You use controlled, highly structured change processes. You emphasize rigorous testing before deploying the update. You maintain comprehensive stakeholder management practices. And most importantly, you always have a rollback plan ready. A rollback plan ensures that if the new update causes the application to behave erratically, you can immediately revert to the older, stable version. Let us quickly recap what we have learned. We explored how the non-deterministic nature of modern models requires us to build privacy and security into the core design of our systems, rather than treating them as an afterthought. We reviewed the 7 elements of privacy by design and the United Kingdom Information Commissioner Office principles, emphasizing data minimization and user rights. We unpacked the challenge of explainability in complex architectures and detailed the governance, consent, and testing documentation needed to satisfy legal requirements like the European Union AI Act. We covered system robustness, highlighting the importance of input sanitization, throttling, and safe failures to defend against emerging threats like prompt injections and model poisoning. And finally, we affirmed that standard change management disciplines, including rollback plans and stakeholder communication, are vital for maintaining these systems over time. To ensure you have mastered these critical concepts, your next step is to practice. All the important topics and frameworks from this session are covered in the multiple choice questions on rucloud.com. I highly recommend that you log in and solve the chapter-wise questions to reinforce your learning and test your understanding before moving on to the next session. Thank you for your focus today, and I will see you in the next session.